So when you're going to load the video source into your Python code, now that video source can be a physical file available in your computer or a webcam. If you are using a laptop, your default webcam, or else it can be like if you are attached USB cameras, USB web cameras into your computer, then that can be the video source. Or even there's a Wi-Fi camera, you can CCTV camera, you can get that loaded as the video source here. So simply what you have to do now, if you are using a normal webcam, the default webcam, you have to put 0 here. So then here, right? So if you have to, if you are loading your default webcam, if you want default webcam, you have to put 0 here. Other than that, if you have any other USB cameras available, so the next available USB camera will be 1. So if you have two web cameras, USB cameras available, one will be 1 and the other one will be 2, right? So the default webcam always will be 0, right? So if you want to load the video file, this is how we are going to give. Like you have to provide the path of that video file like this, right? The absolute path or the relative path. Then the other thing is, if you want to have a Wi-Fi camera, you have to provide the IP address together with the username and password according to the manufacturer. So then you can load the video. So simply this gives you the video source, and this loads the video into this source, whatever the object called source, the video source, right? So then we have the video source loaded here. If we have given the correct path here, now in the example, I'm going to get a physical video file available in my computer. For example, this is the video file that I'm going to use. So if I go to my location quickly, so this is what you have in the videos file, the samples. I have this what you call this face video, this one, right? Okay, so what I'll do here is simply let me get the code back here. So from that video, this is how we are going to read one frame. Now, video is simply a bundle of or set of images, right? So that's something since can you remember the Disney cartoons? So what in cartoons they do, like earlier ones, so they have a set of images drawn like with small movements. So when you are going to play them in high frame rate, you are going to see a movement. So similarly, our cameras, our phones, everything, all the electronic devices captures videos like this. So when you're capturing a video, that means you are taking pictures at a high frame rate and bundle them together. So that's what you call simply a video. So here also, what we are going to do is, we are trying to now, before loading the video, we will try to first read one frame from the camera, and it can be done like this. Source, so source is the video source, and then dot read. So this simply reads one frame from your video source, and that frame is loaded here, and the red simply gives you an indication about whether this video source is available or not. Now, if the video source is available, it gives 1, and if the video source is not available, it gives 0. So it's a binary value. I will explain about this red in detail, but for now, we are going to load the image and load it to this IMG, and we show it, and we wait until a key is pressed. After a key is pressed, we destroy all the windows. So you can no need to do it for a video like this. You can use the web camera. You can load the web camera using 0 here, right? But I will do, since my desktop, I'm doing in this desktop, I will use the video file available in the samples folder. So if you run this, simply, yeah, I think we have to, since earlier code, yeah, I will run this kind of code then probably. Okay, so then the other thing, yeah, here, so you can see, okay, one frame is loaded, right? And can you see the red I have printed? It's true. That means the video source is available. Now, what I mean by if the video source is not available, let's say that I accidentally type something else, and this kind of a video is not actually available physically, right? So in that case, you are going to get false here, and also you get errors since that image cannot be shown, since we can't capture an image. Okay, so that's what the red simply gives you. And yeah, so one frame, right? So now you know what to do to load this again and again. I mean, frame by frame, again and again. So load it as a video and continuously, right? So what we'll do, we will use the infinite loop. Right? We will use the infinite loop. Now the red actually becomes false when the video is not available. And similarly, it will be the same for the, I mean, yeah, I will remove this and explain you, right? And also this one and explain you simply what happens. So here what we will do, we have an infinite loop, and inside the infinite loop, we load the images from the uh, frames from the source, and we load it to the image, and we show it, and we wait like, now we can't wait 0. What happens 0? So infinite loop, you will wait infinite times until a key is pressed. So if you press a key only, then can you see? I have to press keys to pass to the next frame. Since here it waits infinite times until a key is pressed, right? So it shows and waits here, right? So we can't work with that. So what we'll do is that we simply allow not an infinite delay. So 0 is infinite delay, but we will provide something like, let's say 10. So this means 10 millisecond. Sorry. So here the wait delay is given in milliseconds. So I'm waiting here 10 milliseconds, right? I wait here for 10 milliseconds, and I want to show you like wait key. Let's go here, right? The flower example. I quickly go back to the original one. But here, let's say that you are going to provide 10 here. Now this won't, let's say 100. This won't 1000. Let this won't wait infinite times. So let's see. Let me open this one. This one. Yeah. So you can see, okay, if I run this, yeah. So after 1 second, it closes. So 1000 milliseconds, that means 1 second, the window is closed. See, if you provide like 3, let's say, so it will wait 3 seconds. Understood? So that's what happens, right? The other thing is now, okay, let me wait for 10, right? So don't think that's this is a delay. No, this is actually not a delay. This is waiting until a key is pressed. So this is going to wait 10 seconds until a key is pressed. But meantime, if you press a key, if you press a key, then it will be terminated. That means if a key is pressed within millisecond, with this 10,000 millisecond, the windows will be destroyed. But what happens if you put 0? It is an infinite delay. But here it waits only 10 seconds. But if you, in the meantime, if you press a key, it again terminates. But it waits for 10 seconds. And in the 10-second time, if you don't press a key, again, the windows will be destroyed, right? Okay. Yeah. So that's how the wait key works. So here we will allow like 10 milliseconds. So this is like having a delay between each and every frame for 10 milliseconds. So you are going to see the output like this, right? So what's the importance of this delay? So if you remove this delay, right? So that's the most important thing. If you remove this delay, what happens that you are not going to see the output, right? Since you will see something like this, I mean, uh, uh, this kind of stuck thing can be seen, right? So what's the reason for this is that you know that this loop runs in a higher, I mean, like nanosecond time, right? So programs write in nanoseconds, millisecond range, but the physical camera or the physical video, they can't provide images in that kind of speed. So we had to allow a delay, variable delay between each and every frame, right? So that's what we are providing here, right? Okay, so I think Yeah, there's issue with this one. Okay. Um, Fine. Now, quickly. Uh, okay, so if you run this one, now you will see that this works fine, right? So it waits until like 10 milliseconds between each frame, right? So then what I'm going to do here is a very simple thing. Now, we'll see that uh, if you print the ret here, and I will remove the thing, right? So ret is always true since we are capturing images, right? So ret is always true. But at the end of the video, you are going to see that the ret becomes false, right? So this is something like, that means the frames, all the frames of the video is over, right? So it gives a false. Now, but the image is empty. When it tries to like show the image, it gives you the error like the image is empty kind of error, right? So what you can do without now, if this is in the real world, when the video source is not available, your program will be terminated, right? So in order to avoid that, what we can do, we can check the rate, and if it is false, without allowing this to give this error and terminate, what we will do is we will break the loop, right? So then nothing will happen, no errors will be given, it will be broken, the loop will be broken, and all the windows will be destroyed. So let's see. And also we will print the rate as well, so then you can get the idea, right? Right, so you are going to finally get false, right? So finally get false here. Understood. Finally get false, and no any errors given now, since when the ret is false, the loop will be broken, no chance to give an error. And one last thing here, the this waits until the key is pressed, and meantime if a key is pressed, you can take that key into this one. Okay, so let's say in the middle we want to break this loop and terminate this. Now otherwise we have to wait until the end. No, in between you can't change it, but here what we can do, we can check the key, and I'm going to check the key, and I'm going to check whether the key is 27, and if the pressed key is 27, I'm going to break the loop. So this can be used in the middle of the video to break the loop, right? So what I'm doing, like key is equals to 27 and break. So key here 27 is the ASCII value. So if you go to the ASCII table, right? ASCII table, let me show you the ASCII table. So 27, I think this is clear, bit clear, not this one, yes. 27 is the ASCII value of the escape. Now, I'm not saying that always have the escape key, but anyway, if you use the escape key, now if you in the middle, if you press escape, it will be terminated, since if the key is 27, that means escape, this breaks, right? No need to always have it like this. Now let's say M, simple M, okay, 109. So if you can check whether the key pressed is 109, right? So then nothing happens when you are going to press another key, but if you press M, it terminates, right? Understood? Okay, so that can be used to terminate this forever running window. Okay, so then that's pretty much everything, and I will show you one important thing, how we can draw something in this kind of a image or a video, right? So let me get this image so we can draw something here. So we have drawing functions, lot of drawing functions. We will discuss about these things later, but I will take only one drawing function, the rectangle drawing, right? So how we can draw a rectangle in OpenCV, cv2 dot rectangle, and you have to provide where you are going to draw the rectangle, and I'm going to provide the image. This is where I'm going to draw the rectangle. Then you have to provide two coordinates like x1, y1, and x2 and y2. So let me show you what I mean by x1 and y1 and x2 and y2, right? So this is what you mean by that, Right? So if you want to, let's say you have draw a rectangle like this. So in this case, what you have to provide here is right, the x, sorry, let me use another color, like the, right, what you have to provide is the x value and the x1 and the y1, and here also you have to provide the sorry, then you have to provide the w and h of h and this width of the rectangle. So this points coordinate x, y, x and y, right? So then you have to provide then you have to provide the w and h of the rectangle. Is it that the case? I can't exactly remember. Let me see like this. Okay. And then let me explain it later, but I want to get it confirmed whether that's the real case. And then the color of the image, so let me create a green color, and then the line thickness. So let me run this and see the output. Yeah. Yeah. So what you have to provide in order to create a rectangle in OpenCV is simply these things, right? Two, as I can remember. So if you want to create a rectangle, right, you have to provide this x1 and y1 of this coordinate, and also this coordinate like x2 and y2. Right. So these 2 points, x and y, points of those two, right? So what I have given, like here, I have given 20 and 20, and here 100 and 100 to y1 and x1, x2 and y2. Okay, so if you run this one, you will see that this kind of a rectangle is there, right? So if you, I mean, if you simply assign it to the video also, you will see the same kind of, let's say here, right, rectangle in the video, right? And here, this is the line thickness, and this is the x1, y1, x2, and y2. And this is the color BGR compound, and this is the line thickness. So if you line thickness in pixels, so if you increase, the line thickness will be increased. But if you use -1, that means that it will be a closed rectangle, right? So we can draw rectangles, ellipse, circles, and lots of things in OpenCV, but I'm not going to discuss. I will only show you the rectangles, since we will use the rectangles in our implementations, right, later. Okay, then I want to discuss few things about this point operations, and this will be the last section for today's, I mean this OpenCV. And let me show you what I mean by color conversion. So this is pixel-wise operations. I will let you know why these are called pixel-wise operations. But let me show you the output and see what you are going to do here. So first we will load the image. This is something you know, the flower image. Then this function is a very useful function and a very common use function, BGR to gray, let's say, right? So this convert color function, as the name suggests, used to convert the color space of the given image. So you know the flower image is RGB. So what we are going to do, we are going to pass the image into this convert color function, and we have given the color flag. So this is the color conversion flag, and what it does is BGR to gray. So we asked to convert this BGR image to a gray image. So this is a very important thing in our machine learning implementations. We don't use that much color images, we always try to convert it to gray and use it. So you can get the new image into image 2. So I have showed both of them, so you will see what's the difference. See, the image 2 is the gray conversion image, right? So you can use the convert color function in order to convert the color. So we will use these things in our machine learning implementations, but don't think that this color convert color function always converts the color image into gray. No, that's not the scenario. We can use it for like BGR to RGB, right? RGB, right? So red and green, and I mean BGR is image is converted to RGB, right? And BGR to HSV, the HSV color format, right? For color segmentation, we use this HSV color format, and the YUV. So self-driving cars use this YUV color format. So you can use the. Don't worry about the color spaces. Actually, what we need is this gray color, right? RGB to gray. So that's what the color space we are using in most of the machine learning applications, right? And yeah, so the last topic is image thresholding. So here, this is a very important topic, and I will discuss what it does using image thresholding. So I'm going to load the image, the threshold.jpg. So this is the threshold.jpg. So here you can see we have like some kind of strips, color strips, right? So starting from 0, right? So color columns, we can say, right? 0, 1, 2, 3, up to 255, right? So one color is strip. So one column is represented by one color, 0, likewise, right? So what thresholding simply do, now what I have done here, I have loaded the image and showed it. Now, instead of using the cv2.imshow, you can use an alternative function. We have a PLT in MATLAB also. It's provided image showing function called plt.imshow, where you can pass the image and you have to mention the color map you are expecting. So I'm expecting a gray image, so you can use the color map as gray. And yeah, so here what I'll do is I will convert this into this kind of an image. Then what I'll do is get the image like this, and then I'm going to convert, let's say, it to a gray image using convert color, cv2 convert color, and I'll pass the image and mention the color conversion method, cv2 color BGR to gray. So this is the color conversion method we are using, and so you can show it like this. So this is the color conversion. Actually, no need to do the color conversion since it's already gray, but anyway, I'll do it here. Now you can see the yeah, I think since the color conversion is already done, yeah, it's, yeah, let me do it like this now. Yeah, so the image is now, actually it was already in color. Now we have a function called threshold. I will apply it now here. So let thresh equals cv2 dot threshold, cv2 dot threshold, yes, threshold, and the image that I'm going to apply is the gray image. Now make sure that always you are going to apply a grayscale image into this threshold function, and 0, not 0, like 100, 255, and the thresholding method thresh binary, right? And then let me show you the output image. So the output image is given to threshold, right? So let's see the output and let's discuss what I have done here. So here, can you see the binary image? I mean, the grayscale image is converted to a binary image here. So this is a very interesting thing, that actually this threshold function converts a color, I mean a grayscale image into a binary image. So what we are doing here, we pass the grayscale image and we provide a threshold value. So this is the threshold value and this is the upper limit. So what happens? all the pixels that greater than 100, all the pixels that has, now you know in a grayscale image we are having pixel values in between 0 and 255. 0 is black and 255 is white. So what we are doing is all the pixels greater than 100 we make them white, and all the pixels less than 100 will be black, right? So that's what you call thresh binary. So then the return image will be a black and white image. So that's what we have shown here, right? So we have other methods as well, like thresh binary inverse. So this simply the invert of the image, and thresh binary we have other method like trunk. So trunk what thresh, not binary trunk but thresh trunk. So what thresh trunk simply does, now you can see all the pixels greater than this threshold value will be white, and all the pixels less than 100 will be remain as it is. So that's what you call doing trunk. And 20 20 right? So what this simply does is it all the pixels which has a greater, I mean value greater than 100 will be white, but all the pixels which has a value less than 100 will become black. Sorry, all the pixels which has a value greater than 100 remains as it is, right? So you can see the pixels are remains as it is, and all the pixels values greater than 100 will become black, right? So that's what you call thresh inverse. So here, if you like, let me do it for again for the thresh binary, right? So in thresh binary, so if you like see, right? So you can change these values and right, change the threshold and see the output, right? So let me show you a practical example of the thresholding. Now here we have an image like this. So this is simply a coin, set of coins. So we have 5 coins here, and it has a background. So we can use the thresholding in order to filter the coins from the background. So we'll apply thresholding. So I will let me use a value like 100. So what I will do, all the pixels which has a value greater than 100 in this image will become white, and others less than 100 becomes black, right? So this kind of output. So you can adjust these parameters and get a fine-tuned value like this, like so 80. You can see the foreground is extracted, I mean the coins are extracted and the background is eliminated, right? So thresholding. Okay, so this is what we want to discuss before going on to the machine learning or deep learning workshops, the basic things. So we discussed about Python fundamentals, Python basics, as well as some modules like the inbuilt modules and our customized modules, and some helping libraries for our implementation, NumPy, Matplotlib, Pandas, and OpenCV. So please go through the materials and get these things covered. So we will meet on machine learning workshops and deep learning workshop. So you will see that we will use these things that we learned throughout this series in most of the implementation. So thank you very much, and hope to see you all there in our machine learning and deep learning coming workshops. Thank you very much.